In this video, we're going to do a couple more examples of quadratic functions. Okay, so working with quadratic functions. So let's find the first one here as example 2. So suppose our function is 3x squared plus 6x plus 3. Okay, so this is a quadratic because the highest power is 2 of the x. So what we want to do is graph f of x by finding the vertex, the x and y intercepts, and using the axis of symmetry. Okay, so let's start by finding the intercepts. Okay, those are generally a bit easier. So let's do the y-intercept. Okay, so that's where we set x to be 0. Okay, so that's going to be f of 0. So the y value is f of 0, which is 3 times 0 squared plus 6 times 0 plus 3. Okay, so 0, 0 plus 3 is 3. Okay, so we have a y-intercept at the point 0, 3. Okay, so we can plot that. 1, 2, 3. Okay, and now the x-intercepts. Okay, this is when we set y, or f of x, okay, to be 0. So that's going to be 0 is equal to 3x squared plus 6x plus 3. So it looks like I can factor out a 3 so that I have x squared plus 2x plus 1. So I want two numbers that multiply to give 1 and add to give 2. So that's going to be 1 and 1. Actually. So this is going to be 0 equals 3 times x plus 1 all squared. Okay, so that's going to be 0 when x plus 1 all squared is 0 if we divide both sides by 3. And this happens when x plus 1 is 0 or x equals minus 1. Okay, so we only have one x-intercept, and that's going to be at negative 1, 0. Okay, so down here we have an x-intercept of negative 1, 0. Okay, now we want to find the vertex. Okay, so that's not enough yet. Okay, now the vertex, we could complete the square and put this into the vertex form. Okay, or we can just use this rule up above. Okay, so the vertex has x value negative b over 2a. Okay, so for this one, the a is 3, the b is 6, and the c is also 3. Okay, so the vertex is going to have x value negative b over 2a, which is negative 6 over 2 times not a, 3, which is negative 6 over 6, which is negative 1. So we actually have a vertex at the x value negative 1. So the y value is going to be f of negative 1. But we actually already know that's 0. But if you wanted to plug it into the formula, okay, it's going to be 0. Okay, so then this point here is actually the vertex. Maybe I shouldn't have used that color. Okay, so that point is the vertex. Okay, so that means that the axis of symmetry should go through that point. So it's going to be the line x equals negative 1. Okay, so now because that's the axis of symmetry, the graph has to be symmetrical about that line, which means that I know there has to be another point at negative 2, 3. Because it's equally, this is 1 away, so I need another one that's 1 away in the other direction. Because it has to be symmetrical about this line. And now I know enough to graph my function. Okay, so this is the vertex, and then it's a parabola, and it goes up through that point, and on the other side up through that point. So that would be the graph of my function. F of x is 3x squared plus 6x plus 3. Okay, now there's a couple of questions about this function. So what's the domain and the range? Okay, so for any polynomial, for any quadratic function, The domain is all real numbers. So sometimes we write that with a boldface R, or you could write it in interval notation, negative infinity to infinity, or you could write x is between negative infinity and infinity. Those are all saying the same thing. Okay, now the range is all the y values that are hit. Okay, so if I look at this graph, okay, the only y values that it touches are 0 and higher. Okay, so that means that the range is going to be y at least as big as 0, or the interval from 0, including 0, to infinity. Where's the function increasing and where is it decreasing? So it's increasing as we move, so you always want to move to the right. Okay, we want the y values to be going up. So it looks like on this part the y values are going down as I go to the right, but once they hit -1, then they start going up as we go to the right. So as we're moving right, the graph is going up, so it's increasing on the interval from -1 to infinity. Okay, an interval notation. Or as long as x is bigger than -1. And it's decreasing when x is less than -1, so on the interval from negative infinity to -1. Because on that interval, as we go to the right, the y values are coming down. Okay, so that's when it's decreasing. Okay, so that's all there is to do with this function here. Okay, so we graphed it a different way than what we did the previous example 1, using transformations. Here, we just found some points. So we found the y-intercept, the x-intercept, and that happened to be also the vertex of the parabola. And then we used the fact that the symmetry for this parabola goes through the vertex to find this other point, -2, 3. Okay, so there's one more example here. So we want to determine if this function, f of x is 3x squared minus 2x plus 7, has a maximum or minimum value, and what is it? Okay, so we can use the rule right above. So basically, we want to know whether it's opening up or opening down. Okay, so for this function, the a is 3, b is -2, and c is +7. Right? So a is the coefficient of the x squared, b is the coefficient of the x, and c is the constant term. Okay, now because the a value, since a equals 3, which is bigger than 0, that means that the parabola opens up. Okay, so it looks something like that. Okay, so that means that its vertex is going to be a minimum. Okay, so that means that f of x has a minimum value. Okay, so we know it's a minimum. Okay, now we know the minimum value occurs at the vertex. Okay, and we know that the vertex occurs at x equals -b over 2a. So that's -2 over 2 times 3. So that's 2 over 6, which is 1/3. Okay, so the minimum value occurs at 1/3. So that means that the minimum value is the y value, which is f of 1/3. So if I plug in 1/3, it's going to be 3 times 1/3 squared minus 2 times 1/3 plus 7. So that's going to be 3 times 1 over 9 minus 2 over 3 plus 7. And if you compute that, you get 20 over 3, which is approximately 6.667. So that is our minimum value, so y value, for this function. Okay, so you can tell it's a minimum because the a is positive, so the parabola opens up. Okay, so it's opening to the upwards direction, which means that the vertex is going to be the smallest y value. And then you can find the y value because it's going to be at the vertex. So you just want to find where the vertex occurs and then plug that value into your function.